Well, hey there, kiddos. Today we are going to talk about parent functions, and there are several different types of parent functions, which are called parent functions because they're just what they sound like. They're the mommy and the daddy. They are the function that every other function of that type comes from. So they're the mom and the dad of the household, and all the other functions are the kids. Okay. But there's lots and lots of different types of parent functions because it just depends on the type of function you're talking about. We are only going to deal with two in Algebra 1. We're going to deal with what we call linear parent functions, which is just what it sounds like. Linear means it makes a straight line. And then we're going to deal with quadratic parent functions, which are curvy things, and they make these little U's that have a special name we'll talk about in just a minute. But first it says to use your calculator to complete the table for this equation, y equals x, and we're going to plot the points on the coordinate plane. I don't know that we necessarily need a calculator in order to do this because we know that y equals x. That means that if x is -2 and y equals that, then y is also -2. If x is -1, y is also -1 because no matter what we're doing, y has to equal x. So filling in this table, pardon me, happens to be really simple because y has to be the same thing as x. So we're going to plot these points on this graph and we're going to connect to them because we want it to be continuous. So I have -2, -2, -1, -1, 0, 0, 1, 1, 2, 2, 3, 3. And if you will notice, it makes this nice, pretty little line, which we are going to connect and make this nice, pretty little line. That goes through those points. Looks like this. And if you'll notice, that's a pretty little straight line, which was the goal. We wanted a straight line, and since it is a line, and I know that I just have these values in the table, but that line is going to continue on in both directions, so I'm going to put arrows on the ends. That's what those are arrows. So let's list characteristics of the graph. First of all, it's straight. That's the most important thing. It is a straight line. Second of all, it goes through the origin. The origin happens to be the point 0, 0. It's that point in the center of the coordinate plane right here where 0, 0 is, and it goes through the origin. The other thing is that this line, if you're reading your graph from left to right, from here to here, which is how we read all graphs, no matter what language you're reading in, graphs we always read left to right. That's what's cool about math. It is universal. So from left to right, when you are reading this graph, this line from the left side to the right side goes up, it increases. So this is an increasing graph, or you can use the word positive if you want, but it increases. It goes up from left to right. Because this is a straight line that goes through the origin at 0, 0, that is also increasing. If it were decreasing, what I'm about to say would not be true. Then we are going to call this the linear parent function because every other linear graph we make will start from this equation. Any other straight line that we make will start from here, and we will do things to this parent function equation in order to make new lines, like I would add 1 to it, or I would multiply it by 2, and that will change this line, which we will talk about in a few weeks. But it will change this line, but no matter what I do, it always started here. And so this is called the parent function because everything from here, every other straight line started here. Just like my kids, they started with me. And so they are me, but they're a different version of me because, you know, I added something to them or took away depending on how they want to look at it, like their cell phone. Linear parent function, this is the equation, and this is the most important part you need to get from this. The linear parent function is always going to be y equals x because it is a positive increasing line, goes through the origin, and it's, like I said, a line. But that is the equation, and this is going to come up a lot. You need to know that equation. The domain of the linear parent function. We talked about domain and range in our last video, and that's what we did in class today, but this line has arrows on the ends, which means that it extends to the left and to the right forever, but it's also, because it's slanted, going up and down forever. And when that happens, I get to say that my domain, since it goes to the left and to the right forever, is all real numbers, because if you'll remember, that means that it goes from negative infinity to positive infinity, because that's what those arrows do. The range, because it also goes down forever and up forever, is the same thing, and for the same reason. It's also all real numbers, because it goes from negative infinity to positive infinity, just this time it's going up and down instead of side to side. But it's the same. So our second parent function. So now it says use your calculator to complete the table for the equation y equals x squared, and then we're going to plot the points on the coordinate plane. We still don't really need our calculator, but if you want to grab it, go ahead. I'm going to do the positives here first because they're really easy. If x is 0, then 0 squared is 0 because y equals x squared. If x is 1, 1 squared is 1. If x is 2, 2 squared is 4. And 3 squared is 9. Now be careful when you do these negatives, because if you type it in like this onto your calculator, what your calculator understands that you're asking is for the opposite of 1 squared. If you want it to square negative 1, you have to tell it square negative 1. So you have to put the negative in parentheses. Otherwise, it thinks you're asking for 1 squared, the negative of that. Please put it in parentheses. Otherwise, you're going to get it wrong. Because if you think about it, negative 1 squared means negative 1 times negative 1, and I don't care how hard you try, a negative times a negative is going to be a positive. So please put it in parentheses or you'll get the wrong answer. This is 1 squared. My bad. It's just 1. 2 squared, negative 2 squared is still 4. Negative 3 squared is still 9. So if you will look at my y values, they start at 9, 4, 1, 0, 1, 4, 9. They repeat. And there's a reason. So we're going to plot these on our graph. So we're going to start at negative 3, 1, 2, 3, 4, 5, 9. So there's the first point, negative 3, 9. And then I have negative 2, 4. And then I have negative 1, 1. And then I have 0, 0. So there's that origin point again. Then I go to positive 1, 1. Positive 2, 4, and positive 3, 9. And so it's this pretty little symmetrical graph that goes like this. So it makes this pretty little U shape. Please do not draw it and put a point there at the bottom. It is not a V. It makes a nice soft curve. It's not a hard point, it's a soft curve. So make sure that you don't draw it as a V. That's a completely different kind of function. So characteristics of this graph. First of all, it is opening in an upward direction because the arrows face up. So it opens up, and we're going to talk about whether or not that means it's concave up or concave down later. It means it's concave up because its concavity makes this pretty little U, and so it's upwards where it's concave, where it makes the U. But we're just going to say it opens up. This also passes through the origin. Which is that point 0, 0 right in the middle. And so that's also important. And there's one other really important thing. If you will look, we noticed that it repeated here, and it's this nice, pretty little symmetrical curve. And if y'all don't know what the word symmetry means, it's one you should know. Okay, if something is symmetrical, it means that if I put a mirror in the middle of it or drew a line down through the middle of it, then the left half looks exactly like the right half. Or it cuts it exactly in half, and so the two halves match each other. This parabola, that's what it's called. We're going to talk about what that is in a minute. Is symmetrical, and the line that cuts it directly in half is this line right here, and I think it would be better if I actually used a line instead of trying to draw a line. The line that cuts it in half is that line right there, and that line happens to be the y-axis. And so when I'm going to write down characteristics of the graph, it opens up, it passes through the origin, and the y-axis is what we call the axis of symmetry, and all that means is it's the line that cuts it in half. And so the y-axis cuts it in half, and that's sort of a big thing to know. And those are the important characteristics of that graph, and the reason why they are important is because those are the things that make it the parent function. Every other graph of this sort, every other graph that makes this kind of curve will start from this equation. And just like with the linear one, we will either add a number or subtract a number. We might multiply it by something. We might put a negative on it. But every single equation that makes a pretty graph that makes a curve like this started from here, and we just added things to it. So this right here has a fancy name. It's not just a curve. It is called a parabola. No, that is not parabola. We are not in science class. It's not like, you know, we're paramecium or something. It's a parabola. That's how you say the word. Anytime you have a curve that makes this pretty U or an upside down U, it's called a parabola. And all quadratic functions, which are functions that have the x squared in them, okay? All quadratic functions are called parabolas. Any time you graph something makes that pretty little U or upside down U, it's called a parabola, makes it quadratic. Now the domain of the parent function, remember, is how far left and how far right does it go? Well, since it has arrows on the end, that means to the left forever and to the right forever, so it extends both directions, so I get to say that my domain is all real numbers. My range, however, is not all real numbers, because if you go back to the graph and you look at this graph, it extends up forever, but it stops down here at the bottom. It has a minimum. Right here, there is a minimum. And if you look at that point, what does y equal at that point? Well, since it's the origin, y has to equal 0, because it's right in the middle. So this graph starts at 0 and then goes up forever. So you could write the range like this. It goes from 0 to infinity. But if you don't want to write it in set notation, you can just say that the range is all y values that are greater than or equal to 0, because it starts at 0 and then gets bigger forever. So it's 0 and everything bigger. So that's your domain and that's your range. Again, those are important things. So let's practice a few more. So we have 3 more graphs here. We're just going to determine if they're linear, quadratic, or neither. Linear makes a straight line, quadratics make a parabola, and if it is neither, it's not going to be a straight line or a parabola. It's going to be something different. So if you look at number 3, number 3 looks like a straight line to me. It's going down instead of up as you look at the graph, but it's still a straight line. So this is linear. Number 4 makes that pretty little U shape, just like the one that we just graphed. And whenever it makes the pretty U shape, we call it a parabola, and that means it's going to be quadratic. Number 5, though, that thing is not straight. It does not make a U. It makes a weird backwards S-y sort of thing, which is not a straight line, and it is not a parabola, so we get to say this is neither one. You will at some point learn what kind of function that is, but that is not an Algebra 1 concept, so we're just going to say it's neither, because it's not linear, it's not quadratic, and those are the only ones we deal with. So now let's look at it in terms of an equation. Number 6 asks for the parent function of the graph represented by problem number 4. So if we go back over here, here's problem number 4. If you look at problem number 4, we said that it was quadratic. And if you will go back, the equation for the quadratic parent function is y equals x squared. And so instead of y equals x for linear, it's y equals x squared. That makes it quadratic. That's what makes the pretty curve. So the parent function, the equation for the parent function of that graph in problem 4 happens to be y equals x squared, because it's a quadratic function, and the only way to get a quadratic function is to start at y equals x squared. Now 7 has 4 functions, and it says for us to determine if they are linear, quadratic, or neither. Here's how you tell, and we're going to write some short notes underneath so that we can have them. If they are linear, then it has to be in some form of y equals x. So it'll be y equals 2x, y equals 1/4 x, y equals x plus 3, but somehow it's going to have a y and an x and nothing else. If it is quadratic, then it has to be some version of y equals x squared. Either 2x squared, 2x squared minus 4, x squared plus x plus 1. It has an x squared but nothing higher. It has no degree higher than a squared. Okay, but it has to be some version of that x squared. If it is neither, then it doesn't match either of those, and it has a degree higher than an x, or it just doesn't match those other two. So let's look. A, I've got 2/3 x plus 14. Well, it doesn't have an x squared, so I can't call it quadratic. It has a 2/3 with an x and a 14. The only way to get to this from either of these is to start with y equals x. And here's what I meant by adding stuff. So I started with y equals x and I added 14 to it, and then I multiplied it by 2/3, but I still have a y equals x in there somewhere. So this is going to be linear. If I were to graph it, it would make a straight line. Now if you look at C, my bad, let's do B next. If you look at B, I've got 3x plus 5x squared equals -3. There's not a y to be seen anywhere. So we're going to rewrite this so that everything is sorted together. All right? So I'm going to take this -3 and I want to move it to the other side with my other stuff. The only way to do that is to cancel out and put a +3. Well, I can't really add 3 to either of these because it doesn't have an x or an x squared. So this really becomes 3x plus 5x squared plus 3. And since there's nothing left over here, I'm going to put my y. Now I've got a y equals. And what I have, I'm going to change colors here to make it easier to see. I have a y equals, and then I have an x, but I also have an x squared. And I have no degree, which what I mean by that is no exponent larger than a 2 in this problem. So I have a y equals and an x squared, and to that I added a 3x, I added a 3, and I multiplied by 5. But it is still some version of this, so this is going to be quadratic. Now if you look at C, I have 2x cubed plus 3x squared minus x equals y. Well, I've got a y and an x. Also have a y and an x squared. I also have a y and an x to the third. This one has a degree higher than 2 because this exponent is bigger than 2, which means it cannot be quadratic and it cannot be linear, so this one is going to be neither. And apparently, I just wrote the word neither down here and we're not even sure why. So let's double check this, okay? I have y equals 2x plus 5 plus 2x. So we're going to, oh, I know why I wrote the word neither down there. That was from earlier when I was writing notes. It doesn't go with part D. We're going to simplify D before we do anything with it because I can put this 2x and this 2x together. So this is really 4x plus 5 equals y. And if you compare that to my parent functions, y equals x or y equals x squared, this is some version of y equals x because you have a y equals and an x, and what I did to that x was I multiplied by 4 and I added 5. I didn't square it, I didn't do anything else with it, so it is just this y equals x. It's a version of that, so this is linear. And so that's how you determine it. You look at it and see, is it some version of y equals x, or is it some version of y equals x squared, and if it's not, then it's neither. Otherwise, it's one of these two. So those are your options, linear, quadratic, or neither. Those are your parent functions, the things that you really need to memorize. Quadratic parent function is y equals x squared. Linear parent function is y equals x. And those are the two big things. So we will practice this when you come to class tomorrow. I will see you then.